This is a very similar problem, so let's do it. So here's my function. Oops, my pen working here. Here's my function. So I'm going to rewrite this as y equals x to the negative 2 before I do anything. Oop, let me get rid of that. Okay. So then I'm ready to take the derivative with respect to t. Remember, derivative with respect to t is different, right? So on this left-hand side, let me get a different color. I get dy over dt equals negative 2 x to the negative 3 times dx over dt. Okay, so let's see what I've got here. Before I even do much, I'm going to rewrite this negative exponent and put it in the denominator. So it looks like that. Okay, so let's see what I've got to plug in. Oh, I'm trying to solve for that. That's good. And I want to plug in x equals negative 1. So let me bring it up here, dy over dt. So I'd have a negative 2, a negative 1 cubed, and then times a dx over dt, which is a 5. So this gives me a positive 2 times a 5, and that gives me a 10. And that's it. Okay, let's look at this one. Here my x equals is this function. Here's my given rate, find this, when this. Okay, so to take the derivative of this, taking the derivative with respect to t, you get dx over dt, 3y squared dy over dt. Derivative of y with respect to t is dy over dt, not y prime. I will ream you on points. I will take many points off if you put y prime. Can't do that. It's not just me, it's all mathematicians. So now I'm going to plug in the when y equals 2. And the dy over dt is 5. Oh, and look at that. There it is. It's ready to go. Let's do one that's very similar. Okay, so I want to find dy over dt. So I'm going to take the derivative. So I'm just going to, you don't have to write it every single time, but I'm just going to remind you what we're doing. We're taking the derivative with respect to t of both sides. So the derivative of this would be 2y dy over dt, because that's the derivative of the inside. Here I get 2x dx over dt plus, and then here derivative of x is just dx over dt. Let's see what I've got. So I see dx over dt is 3, so I get to plug that in. So 3 and 3. Do they tell me what x is? Oh, they do. So this is 2. So 2 times 2 is 4. And I've got this 2y dy over dt. Okay, here's where it's getting a little trickier. So I've got 2y dy over dt. So that's 12 plus 3 is 15. All right. Let's just divide through by the 2 first. Equals 15 over 2. And you can leave it like that. You don't need to put decimals. How am I going to find y? Think about it. Don't I have x equal 2? And don't I have the function? Oh, I do. So couldn't I say y squared is equal to 4 plus 2? So y squared is equal to 6. And then I could say y is equal to plus or minus root 6, right? So dy over dt would be 15 over 2. And then I would have plus or minus, well, let me just put it up here, plus or minus root 6. And then divide by that, right? 15 over 2. And I'd have plus or minus 1 over root 6. That's pretty ugly, but it's okay. It's legit. Okay, let's look at this one. So here, I'm giving you dx over dt. I want you to find dy over dt. So you're going to find this as a pattern. Find a rate, given a rate, when information, and an equation. So you know in order to take the derivative of this equation that you need to do product rule, right? So this needs product rule. So you do it. First d second plus second d first, right? xy prime plus y dx over dt equals 0. So now let's plug the information in. So if I plug in x equal 8, right? Plug in x equal 8 right there. If I plug in dx over dt is 10, there it is. What am I left with? I don't have what y is equal to. So I put the x equal 8 back into the original problem, and that'll tell me what y is. So I didn't do this so well, so let me just write it again. So once I take this, and I plug in what I have, so I'd have x, and then dy over dt plus y, dx over dt, which I know is 10, equals 0. So dy over dt is what I'm trying to solve for. They gave me x is 8. So how do I find what the y is equal to? So this is going to be a common dilemma. So that's where you put your the when information into your original equation. So if I put x equal 8 into here, I get 8y equals 4. So that means y equals 1/2. And so that's what you plug in for y. And then you can solve for dy over dt. All right, let's do one on our own. Here we go. So here's the given rate, the find rate, the when information. So to start to take the derivative on the left-hand side, you see its product rule, right? First d second plus second d first equals derivative of 4y would be 4 dy over dt. Oh, and look at that. The derivative of -6 is 0. All right, so let's see what I've got. I'm going to plug in x equal 1. So I get 1, and then dy over dt is what I'm trying to solve for. So let's just leave that there. Plus y, oh, look at that, dx over dt, they give me. So it's 10 equals 4, and I'm going to carry along this dy over dt. So now let's look and see what we can do. If I plug in x equal 1 into here, will that help me find y? I think it will. So I get y is equal to 4y minus 6. So -3y equals -6. So y is -2. There it is. So let's plug it in. So I get dy over dt plus, no, actually minus, right? Minus, minus 2 times 10, so that would be a 20, equals 4 dy over dt. So we want to get all the dy over dt's to one side. So if I subtract that, that'd give me 3 dy over dt is -20. And so finally, dy over dt would be -20 over 3.